We've been working for the last few days to install a new network of instruments around the volcano. So at this site we've got a seismometer and a magnetometer. The seismometer records sort of the ground motion, things like earthquakes, or in volcanic environments we typically have this thing called tremor. And the magnetometer is recording the local magnetic field and changes related to, or hopefully related to, changes in the volcanic system. Elsewhere, we've deployed a CO2 soil probe. This measures the sort of flux of gas up through the soil. That's inside the crater area where there's lots of gas and water and all these things going on. And then we also have a GNSS instrument, which is essentially an antenna that tells you exactly where it is in space, and you see how that moves through time, and it tells you something about, hopefully, what's going on inside the volcano. These have to be secure to last. These are permanent installations. These have to be put together to last all conditions for as long as possible without having to return and fix things all the time. One of the big challenges we face with volcanic systems around the world is not all of them are easy to get to. Not all of them can you drive up to and install instruments and send data back via established radio links or cellular networks. So this platform that we've been developing, we can take all different types of instruments, integrate them together into a system that can harvest and telemeter the data back to our servers. So one of the real pushes that we've made is to try and get that data back from these really remote places around the world in as close to real time as possible. In some instances, getting that data back quickly, having systems in place to distribute that data, to get it to the people that need it in order to process it, to incorporate it into the models that they have built and use to track unrest essentially in the volcanic systems and assess how likely a volcanic eruption is in the near future is really important. So at Poás Volcano, it's a system where it seems like the most useful data is going to come from as close to the vent as possible, and that means we have to get all of our equipment out there, including the batteries to make sure everything's powered, and the crater itself is this very steep-sided bowl from which you have to descend 100 or 200 meters down the side of this bowl to access the crater area, all while carrying the heavy equipment like the infrastructure for the power, the solar panels, the steel rods we use to build the frames for them. Every volcanic system, unfortunately, is unique in its own way, and making it quite difficult to take lessons you learn elsewhere and translate them. One of the best things we can do is go to every volcano that we can, add instruments like we've been doing this week, and record that data, analyze that data, and over time, as we build up a kind of time series of data that we can relate to the volcanic activity as we observe it in that time, we can try to better understand each individual system. It requires a big team, so you think about having to scale that up to the hundreds of volcanoes around the world, then you can kind of understand the scale of the challenge that we have in adequately instrumenting all the volcanic systems that pose a sort of danger to the people that live near them.